Hi everybody, Buckley here. Just wanted to go through some information on the design project that'll be helpful as you're moving into your milestone number 5. Milestone number 5 is about generating metrics and target values. So just a refresher on what's expected here. So we are firmly in phase 1 of the design process, which is defining the problem. We are wrapping that up. So this milestone will be the last milestone in the define phase of the design process. Next up is concepts. Third phase is the detailed design, and fourth phase is the testing. So just a preview, we'll actually be getting through concepts before spring break, and then we'll be saving design and test until after. Okay, so remember, we're going through all this careful detail so that we make small iterations between our steps, not these big oh shit moments where you have to go back to the drawing board. Okay. All right, so let's delve a little bit deeper into the define phase and finish that out. So just to remind everybody where we've been. So problem definition consists of a couple key things. First is providing sufficient background information to clearly motivate your design solution. Okay, so our milestone number 2, which was our HDFS interview, and our benchmarking, which was milestone number 3, are really digging into the background. You've clearly and succinctly developed a project scope. Okay, that was this past milestone, milestone number 4. And then this milestone, we're getting into defining and prioritizing stakeholder wants and constraints, as well as developing metrics and target values. So if you don't get this right on the first go round with your milestone number 5, don't worry. This is something that we're going to continually refine until it looks good for your project. Okay, so milestone number 5 is really to get you started on this and to get those looking good and get you some feedback. All right, so I want to remind everybody where we are in terms of the example project that I'm working through with Keith. So we have this Team 000, me, Keith, and our 2 lead TAs are working on a modern art construction toy set. The big picture, so going through our background and our motivation, big picture is to introduce modern art, introduce kids to modern art. Modern art itself is a great way to engage kids, right, because it has a lot of fundamental shapes. So what's been done before? Well, there's a lot of luxury toys from artists and designers on the market in the modern art space, but they're really expensive, and the ones that do exist tend to be block sets and that sort of thing. So the gap is that there really aren't many toys out there that use modern art concepts for kids to create their own work. So how could we use some of the same concepts that the artists are using to create work that looks like modern art, that's following those same principles, that's also affordable? So our project scope is to develop a modern art themed toy that promotes constructive play in kids in our age group that relates directly to the underlying concepts of modern art from the toy that it's the form that it's emulating. All right, so at this point you should be at a similar step, right? So you've got your 4-paragraph essay all outlined, your project scope, and now we're ready to really dig in on our end user wants, our project constraints, and that metrics table. So what we come up to next is defining and prioritizing wants and constraints. So just so we're all on the same page with each of these words, wants we tend to associate with a stakeholder. So a stakeholder is an individual or entity with business or personal interest in your design. A constraint is a design requirement that must be met, or your design is essentially a failure, right? The design fails catastrophically. There's no room for interpretation on a constraint. You either meet it or you don't, and you have to meet it with your project. A want is a desirable characteristic of your design, generally specified by your stakeholder. There's some flexibility in terms of wants, so you may not completely hit a want in your final design. And that's okay. That doesn't mean it fails. And wants are prioritized. Constraints are always a top priority. You must hit the constraints, but wants are generally prioritized. Okay, so let's start thinking about who your stakeholders are. And if you're following along with this, this is a good time to kind of pause and maybe discuss with your team. Who are your stakeholders? All right, for me, my stakeholders are the kids that I'm designing the toy for. Right? Parents and early childhood educators are the ones that are actually buying these toys. Our kids are 4 to 7 years old, so they alone do not have a lot of purchasing power. Retailers, right? Toy stores, department stores who would be selling this product. and manufacturers and distributors who would actually produce the product. So those are the stakeholders that I came up with. What are some constraints on your design? Again, if you're following along, good time to pause and talk with your teammates. It's also a good time to maybe look at the project summary that was originally posted. I have a lot of the constraints that we mandated in that summary, but you may have come up with some other constraints as well. All right, the constraints that I came up with are safety, right? So these toys must be safe for kids to use. There's really no give on that. The other is size. That's a constraint that we put on you. We want the toys to be within a certain size so that everybody uses a reasonable amount of materials and we don't have storage issues, blah, blah, blah. The other is manufacturing. So we have a requirement for manufacturing that your project be sufficiently complex, okay? And then there is a prototyping budget as well as a prototyping timeline, right? So you need to finish this project out by the end of the semester. All right, here's where you do some creative thinking on your own here. What wants are you hearing from your stakeholders? So you've gone out, you've talked to your HDFS consultant, you've looked at some benchmarks. What wants are there from your stakeholders? All right, the ones that I'm hearing are as follows. My stakeholders, parents, educators, the kids themselves want the toy to be engaging. They also want it to be relatively low cost, durable, educational, and I personally, because I've identified this gap in the market, want it to be recognizable as modern art. Okay, you may have others, so et cetera, right? So these are the wants that I've identified. Your wants may overlap somewhat with what I presented here, but you're also going to have some unique wants to what you're hearing from your stakeholders. Okay, so what do we do from here? Well, ideally, when you're generating these wants, you're interacting with your stakeholders. This is one of my stakeholders that I use quite frequently. So I have a now 4-year-old who's in my world here. This is Macy, my niece, so she's a good toy tester. But you guys, again, your HDFS consultant is a perfect person to check with. Also, any kids that are in your family network are also good to bounce ideas off of, give you a quick feedback. So you should be hearing from people about their wants. Right, so you want to make sure that you're synthesizing information across your stakeholders, your HDFS consultant, your benchmarks that give you some clue of what maybe the market will want, other people that you're talking to help prioritize your wants. So it's very important to prioritize your wants. So my wants, again, if I were to prioritize them in the following order, I may come up with a toy idea that looks something like this. So my wants list number 1 was top of the list is engaging, next is low cost, third is durable, then educational, then recognizable as modern art. And this is a benchmark that I've found that actually I think would be similar to something that I would design to match this list, right? Top of the list is engaging, durable, low cost. The recognizable as modern art is very low on the list. This is not actually something that's themed for modern art, right? It doesn't tie in directly to some artist. Contrast that with what would be designed if this were my list. So if I bumped this recognizable as modern art all the way up to the top, I might get something that is very tied in. This is actually directly linked out of my benchmarks from a piece of modern art called a Yashimoto cube. And so this is almost like exactly like the artist's work, but it is not super durable. It's definitely expensive, questionable on the engaging for the age group that we're talking about. So this slide is just to remind you that ordering of your wants really, really matters, right? So it's going to really drive your design, because basically what we're going to do is we're going to say, okay, the metrics that are associated with this top want, you really have to hit them, right? Those have to be achieved first before you move down the list. All right, so take some time to prioritize your wants. Well, how should you prioritize your wants? Well, you should be listening to your stakeholders, right? You also need to report on that. So we're not requiring this for milestone number 5, but you should be noting how you have developed your priorities for your wants. A bad way to do it is sort of like to just generally as a group come up with this list, right, and plunk it down on paper. And when you document it, it's really obvious when you've done something like that, right? So a bad example, we generated a list of constraints and wants. A better example is constraints were specified by national standards and course requirements. Wants were identified and prioritized through various user-centered research techniques, including interviews and surveys, okay? So going back to your HDFS consultant saying, hey, does this look like a reasonable order of wants is something you want to practice doing. Okay, so enough on that. So here are some examples of descriptions and constraints and wants. Again, we're not requiring you to write this in milestone number 5, but in your phase 1 and 2 report, we're going to be expecting to see this. So your phase 1 and 2 report will be due after the break, after spring break. So it's coming up. It's worth documenting right now. So what are we expecting? Things like this for the safety standard, right? I would write down meets national, international toy safety standards. Low cost, the design can be realized in its final commercial form with relatively low manufacturing costs. Engaging children of the target age group naturally and willingly interact with the toy design. Okay, so those are some good descriptions. Okay, so again, I want to stress that right now we've gone through the first 3 items. We've provided sufficient background information. We've clearly and succinctly stated the project scope. And then we just practice defining and prioritizing stakeholder wants and constraints. Okay, so take your time doing this. Document as much as possible. It'll save you time when you go to write up your phase 1 and 2 report. All right, for milestone number 5, what we're really focusing on wanting to see from you is this last bullet point here, developing metrics with measurable reference target values. Okay, so let's review what we mean by that. Metrics specify exactly how you want to achieve your design constraints and wants, right? So there's something that's measurable that tells you whether you've hit it or not. So let's look at some of the constraints and wants that were associated with our toy design project. So the first is safe. Okay, that's a constraint. The toy must be safe. The metric that is associated with it is whether it meets the International Toy Safety Standard, ASTM F963-11. And you guys are going to be required to meet this safety standard directly. And I'll get into that a little bit later in this presentation. But the metric is yes, no, whether or not you've met this safety standard. Low cost, the metric associated with that is basically the estimated cost to manufacture the toy in bulk, right? So that's a measurable thing. Engaging, right? So engaging is a want. Low cost is also a want. So we've got constraint, want. Engaging is a want that sometimes I see a lot of students who really don't come up with a valid metric that's associated with it. You want to make sure that you've got something that you can sink your teeth into, right? When we're looking at engaging, you want a measure of engagement from the kids, right? So our measure that we're choosing to do, and there's various ways to do this, is the choice to interact with the toy. So our kids choosing to interact without being coerced with your toy, and how long are they interacting with that toy. So actually I have 2 metrics that are associated with the want of engaging. You're going to need to come up with your own. If you think these are valid, that's great, but make sure you really think about it as a team. All right, so you're going to present your metrics and target values in a standard metrics table. This is what we expect to see. The first is a priority to your metrics. So we want you to show us which metrics are very high priority and which are lower priority. Obviously, any metric associated with a constraint is going to be a number 1 or a top priority. So I'm looking here at safety, and I have a metric which is minimum part size. That's part of this ASTM toy safety standard, and it needs to pass the small parts test, which is part of the standard. Again, I'll get into this standard over the course of a couple slides a little later in this presentation. Okay. The second is another test with ASTM. It's the sharp edge test. It's associated with that same constraint, which is safety, and it's the minimum part radius test. Okay, here's a manufacturing cost, which is a want, so that's a low priority for me, or lower priority. Manufacturing costs, I want to target $10 to $15 per unit. Okay, and here's the justification that goes along with it. So very important that you're creating a reference for every target value that you've put up here. So my reference on the prior slide was the safety standard itself, which is fine. When I'm creating sort of my own target value, synthesizing a lot of information, I want to make sure that I jot down how I did that, right? So I'm doing this with this write-up, which would be in an appendix for my target values. So as a rule of thumb, cost of goods for commercial toys are 50% retail price. Our benchmarks and early user-centered research suggest that our design may retail for 20 to 30 bucks, which would place our manufacturing costs at 10 to 15. Okay, so that's citing your benchmark, saying, okay, this is about what the price is coming in at. Rule of thumb, your cost of goods is about half of your retail price, right? So that's how I got that 10 to 15 per unit. Okay, so it doesn't need to be complicated, it doesn't need to be long, but you need to show me that you've justified your target values. All right, your justification can include fair and reasonable tests that you'll perform to validate your metric. And this validation will happen in phase 4, right, which is the testing portion of the design process. But it doesn't mean that you don't need to think about it right now, right? So here we are with our want of being engaging. And the metric, this one metric that we're looking at is choice to interact. So the choice to interact, if I'm looking at Appendix C, okay, I'm going to design a test. This is the test that I propose. A custom test has been designed to measure choice to interact with our toy. 5 to 10 children will be presented with 2 toys, one of which is ours and one is an equivalent benchmark. If the child engages with our toy over 40% of the time during a 20-minute play period, we will consider the toy to be at least as engaging as the benchmark. This test protocol was developed in partnership with our consultant. Okay, so come up with a way, if you've got, which you probably do, these sort of fuzzier, softer wants to really put a metric associated with it. Okay, so again, I have my want, I have something measurable that's associated with it, I have a target value, and that is reference that I've explained how I'm going to achieve that target value. Okay, so we've put a lot of time into our metrics here, right? And this is what I want to stress. This is the purpose of this review talk as well. You're going to go back to these metrics repeatedly, right? So in the define phase where you are right now, you're defining what those metrics and target values are. Concept generation, we're going to weigh our concept versus these metrics. Design, you're going to make design decisions based on the metrics, and testing, you're going to test whether you've met them. So it's really, really important to take the time now to lay out these metrics, and if we give you some feedback that they're not quite right, to make sure that you modify your design or your metrics table to really nail those down. So my rule of thumb is do not half-ass on my metrics. Metrics are linked to wants and constraints. They have concrete target values. They're justified, and they can be tested with the final design. So don't half-ass them, okay? All right, so that's what I have to say on metrics. If you want to hear this again, obviously rewind. Try to go through this as a group. Make sure everybody in the group is in the same place. For those of you who have not taken Engineering 101, you may want to listen to this talk a couple times and ask me, ask one of your TAs, or ask your teammates if anything is not clear. All right, I want to talk a bit about the constraints for this project specifically right now. Okay, so this is backtracking a little bit. I want to explain exactly what constraints are in place. Note that you can add on to this list of constraints if you want. Make sure it's truly a constraint, though, and not just a want. But the constraints that we've given to you are, first is safety. So your toy must meet ASTM 963-11, which I'm providing to you in the /resources/design project folder. So you can see the ASTM standard in its full glory. I'm going to do a very quick run through of it in a minute because it can be a little intimidating. I think it's like 60 pages long. Okay, so I'll give you the highlights and then we'll keep coming back to it throughout the course. The second constraint is size. So your toy must fit within 2 foot by 2 foot by 2 foot packaging, either assembled or disassembled. Okay, so nothing bigger than 2 by 2 by 2. Over the years, we've had some very large projects that were put together. Some of them which were very good. It's just that it makes it really difficult for us to store them and everything else, and also to give them away. So 2 by 2 by 2. The manufacturing constraint is for the purpose of this course, your design must involve sufficiently complex manufacturing practices. These constraints and the manufacturing constraint are taken directly from the project summary. So if you haven't gone through that as a team yet, make sure that you do. If you look within the manufacturing plan in the project summary, you're going to see this. So you need at least 3 manufacturing practices, and those manufacturing practices may include multiple carpentry operations, multiple fasteners, 3D printing, laser cutting, CNC routing, plastic molding and or hot wire foam cutting, vacuum forming, sewing, and soldering or wiring. So making sure that you have at least 3 of these operations in your toy design, okay? And we'll be going over more of these operations later in the course, but for right now, you've been through most of the carpentry, and we'll be doing 3D printing, laser cutting, and CNC routing. All right, I want to dig a little bit now into the ASTM Toy Safety Standard. You've been given this document in PDF form. Again, it's about 60 pages long. The designation is F693-11. ASTM is American Society for Testing of Materials. It is one of the 2 major standards organizations in the world. The other one is ISO. But any toy that is marketed or sold in the United States has to pass ASTM F963-11, right? So some knowledge of the standard is absolutely a must for your toy design. Okay, so I'm going to go over the 4 tests that are essential that your toy passes as part of this safety standard. Okay, and those are the use and abuse test, the sharp edge test, the small parts test, and the cord strangulation test. There are others, so if you're creating a design that involves magnets, if you're creating a design that involves circuits, if you've got something that's a ride-on toy for some reason, there are also parts of the safety standard that are relevant to that, and myself or the TAs will help you find those parts of the standard. Okay, but the 4 that cover most everything are the use and abuse, sharp edge, small parts, and cord strangulation. So here they are in summary form. Use and abuse testing simulates all the way that kids can basically break your toy. So the trick here is to look at the different types of testing. So the 2 that pretty much everything gets tested by drop test and by compression test. If you have parts that twist together, you may also need a torque test. If things are getting stretched and broken, a tension test, and then a flexure test is for bending. But I want to focus for a second on the drop test and the compression test. So the drop test, so your testing category is actually not going to be the highlighted one. It's going to be over 36 to 96. This is months, okay? So your toy needs to survive a drop from 4 feet, or 4 times from 3 feet high. So dropping your toy on linoleum from 3 feet is a must. Your toy, it can break when it's being dropped from this height, but it cannot produce anything that has a sharp edge or that produces a small part when you drop it. So dropping your toy, making sure that it does not break into pieces that can then cut a kid is super important. The other is the compression test. Again, I've highlighted the wrong region here. This should go down, but you're 36 to 96. So 36 is 3 years old. 96 is 6, 7, 8 years old. 8 years old for 96, okay? So you're in this category. So your toys need to sustain 30 pounds of compressive force. Again, it can break under 30 pounds, but it can't produce anything sharp, okay? Sharp edge test is what's used to determine whether you have a sharp part. Okay, this is a test that we will have set up in the design studio for you so you can test your parts. But it's basically, there's a mandrel, so there's a spinning object here. This is it's supposed to simulate a kid's finger. And you wind some Teflon tape around this spinning mandrel. And then you move your part up and touch the spinning mandrel with your part and try to cut off the Teflon tape. So you have to push with about a little, like 1.5 pounds, push your part up against this spinning Teflon tape with 1.5 pounds. If it cuts the tape, your part has a sharp edge. So it needs to pass this test. All right, small parts test is something that actually will not be applicable to your toys because your toys are being marketed to 4 to 7-year-olds. But just for future reference, if your toy is being marketed to kids under 3, it has to pass a small parts test. And what this is it's basically simulating a kid's esophagus, a child's esophagus. So it's a little tube that has the diameter of a child's, the average child's esophagus, and the depth of an average child's esophagus. So you would place your toy inside of this tube, and if the toy does not stick out, so it would sit, the toy would sit within this cylinder, kind of in this little well here, this trapezoidal well, and if it sits within the well without it popping out from the top, you have failed the small parts test. The way to think of this is if a kid can put the object down his or her throat, and a parent can't then pull it back out of their throat, you have a problem. So you guys, again, because you're dealing with kids that are above 4 years old, toy parts do not need to pass the choking standard. However, I would say you open up your market even further if you're able to pass this test. So this is the small parts test. We have small parts testers in the design studio, and we'll have those out for you as well. The last test that you should at least know about, okay, this is again for kids that are younger, but it opens up the market for older kids if you can pass this. For kids 18 months of age or younger, you need to watch out for strangulation. So can they wrap a cord around themselves, around their neck, and choke themselves by accident? So cord straps and elastics in toys for kids in this age group have to be less than 12 inches in length, okay? They also have to be able to be pulled off. So not relevant for your age group, but again, it opens up the market if you're able to pass that. So just to reinforce, your toys need to pass the use and abuse testing, the drop test and the compression test, and also the sharp edge test. If you can get them to pass the small parts and the cord strangulation, that opens up the market even more. The ASTM toy standard will be posted in its full glory on /resources/design project, and we'll be using it as a guide. I will periodically reference it in class as we go along. All right, folks, that's about all I have for you, okay, on this stage of the design process. Again, we're wrapping up phase 1 with your metrics table and milestone number 5. Make sure that you document things as you go. That'll save you a lot of time as you're writing up your report. Thanks for listening. Take care. Bye-bye.